Hi everyone, this is Mrs. Kraus. This is our second video on the Unit 2 Part 1 notes on atomic and molecular structure. In our last video, we ended by discussing how chemical bonds hold atoms together, like they do in this water molecule here, and that valence electrons, or the electrons that are furthest out from the nucleus of an atom, are available to participate in chemical bonds. We have two main types of chemical bonds, ionic bonds and covalent bonds. In number 15, we are going to define those two types of chemical bonds. So let's get started. An ionic bond is when we have electrons being transferred between two atoms. Let's take a look at the picture here, and you may want to draw this picture in your notes. So in this picture, we're seeing sodium donating an electron to chlorine. Because an electron has a negative charge, chlorine ends up with an extra negative charge, so it's no longer a neutral atom. If sodium is losing an electron, losing a negative charge is like gaining a positive charge. So sodium ends up positive. Now, we call the Na plus and Cl minus ions, which means they are charged atoms. And when sodium has a positive charge and chlorine has a negative charge, they're attracted to each other because opposite charges attract. Opposites attract. Think of dating. So we call that attraction between these ions an ionic bond. So that's why we're defining the force of attraction between oppositely charged ions, which are atoms that gain or lose electrons. And in this situation, an electron is being transferred from sodium to chlorine. So again, you're going to put the definition under number 15, but you should also draw this picture of an ionic bond at the bottom of your page. Our next type of bond is a covalent bond. Our definition of a covalent bond is a chemical bond that forms when two atoms share electrons. For example, the water molecule H2O is held together by covalent bonds. We see oxygen and one of the hydrogens sharing a pair of electrons. I have an arrow here to show that one of the electrons came from hydrogen, and an arrow here to show that one of the electrons came from oxygen. Holding these two shared electrons creates a covalent bond. We also see a covalent bond over here where we have another shared electron pair, one donated from oxygen and one from hydrogen. Okay. So ionic bonds occur when there's a transfer of an electron from one atom to another, and a covalent bond occurs when atoms share a pair of electrons. Okay. So you're going to put the definition for covalent bond under number 15, and you are going to draw the picture for a covalent bond in the space below. Now, water is technically a compound because a compound is atoms combined in definite proportions, which we do see with water. But when a compound is held together by covalent bonds, we have a more specific name for it. We call it a molecule. So when atoms are joined together by covalent bonds, that's a molecule. If they're joined by ionic bonds, we just call it a compound. No more specific name. So we're going to fill in molecule for number 16. And then for number 17, just for funsies, another type of bond is called van der Waals forces. This doesn't happen within a single compound or molecule. It happens between two different molecules. when those molecules come close together, you could end up with a slight attraction if those two molecules have opposite charges in certain regions, because opposites attract. So this is another case of opposites attracting, but it happens between two different molecules. We see this with a gecko or a frog sticking to the surface that it's walking on with its toes. The reason it's able to stick is the molecules in the toes of that gecko or frog are able to form van der Waals forces with the surface that they're standing upon. Now, the good thing about van der Waals forces is they're weak. So they're able to form to help them stick there, but they're also able to pull their foot off no problem. We wouldn't want to have an ionic or a covalent bond for that because it would be much harder to break and the animal couldn't move. Okay. And that's it for atomic and molecular structure. Thanks, guys. Oh, wait. Make sure you fill in for number 17, van der Waals forces. All right. Thank you.